Thank you very much for your introduction. I'm very pleased that I can talk about our project at this conference. In fact, our goal is in a way also to show another application of ACTUS, and the secondary goal is to lower the threshold for using ACTUS, because for someone who is new to ACTUS or who has never used it, it's in fact not that easy. And so, okay. So the outline of our talk, I talk about a project funded by the Swiss National Science Foundation. It's a 4-year project called Data-Driven Financial and Risk Regulatory Reporting. So the official goal is to build a pilot for an open automated reporting system. So I first gives So first I will go give some details about the project. Then I talk a little bit about the background, which is the last financial crisis. Then our vision, our approach. Then I introduced a component-based environment in order to build the, this works, but I wanted to do it here with this, but well, anyway, it's not important. It's okay. So then I introduced this component-based environment, which are the basic building blocks of the ecosystem. I make some comments about the relationship between ACTUS and our DAT43 project. And at the end, I have a demo that is deployed on the internet, and everyone can go to it. So let's start about the project. The name I already mentioned. It's a research project, and it's a special program called this Bridge Discovery Program, situated between basis research and development. The duration is 4 years. It started 2 years ago with a volume of 1.5 million Swiss francs, and we are 3 universities. My university, which is the Zurich University of Applied Sciences, then the Luzern University of Applied Sciences and Arts, and the University of Zurich. Our goal is to develop a scalable infrastructure for next generation regulation of financial system. And the approach, we use the cash flow-based forward-looking analysis of financial risk. And this is based on the ACTUS technology as an universal infrastructural layer. So about ACTUS, you have heard up to now in every talk, or almost every talk. So I don't need to explain what it is. We have 2 additional topics. We have the development of risk measures, especially as to the stability of the financial system, and the modeling of DeFi and blockchain products with the goal to include them into the regulation, which means specifically to use ACTUS for the representation of smart contracts. So what is the background? During the build-up of the last 2008 financial crisis, the regulation failed. The main reasons: we had limited data flows and analytics. The data were highly aggregated, and the quantitative matrices were backward looking. The reporting happened as it is still happening today. The regulator sends out templates, and the banks must fill in the templates. The aggregation of data at Bank B and at Bank A and at Bank B is done slightly differently, so that 2 reports from 2 different banks are not really comparable. Now, after the crisis, we had new regulations, we had new institutions. Unfortunately, the technological data challenge and the analytical challenges were not appropriately addressed. We are still not able to aggregate data automatically, quickly, in a transparent way. So what we still need is the overhaul of the financial and regulatory reporting infrastructure, suitable digital financial infrastructure, and better analytics. And this is where our vision comes into play. We would like to transform the financial reporting infrastructure. So we need a standardized platform-based digital reporting ecosystem. And the starting point are the individual financial contracts. Key enabler, a standardized digital container-based representation of financial contract data and algorithm, which is ACTUS, blockchain and smart contracts, big data technology, and automated state-of-the-art financial modeling and analytics. So at RIGHT, this is how we imagine a regulatory reporting system tomorrow. It should be pull-based. So the regulator, do you see the cursor? Yes. Okay. So the regulator pulls the data from the bank at a granular level. It should be in the ACTUS standards. So the banks must transform the data onto the ACTUS standards. And then the regulator uses his or her own economic financial models and runs the ACTUS algorithm on the data with this model and generates the cash flows. And from the cash flows, all kind of analytics can be calculated, the balance sheet, the income report, and the liquidity reports, and especially also regulatory analysis and the reporting logic. And what's also very important, if the regulator wants new types of analytics, it can be much more easily implemented than today. And in addition, it enables the flexible creation of regulatory reports at any time. As today, we have the weather report at any time, any hour, even for every point in the world. And so the idea is that the regulator should be able to get a report at any time that he wants. And it is not necessary that the regulator carries out these computations. It may be done by trusted third party. There may be special institutions created for doing this. So what is the expected economic and societal impact? This represents a real paradigm shift of financial regulation. Highly automated, flexible, transparent, comparable reports. Improved adaptability to new situations. Realistic systemic forward-looking. I don't know. Yeah, it comes. Realistic systemic analysis becomes possible, and it is forward-looking, so that the regulator has an increased ability to take measures sufficiently early to mitigate adverse events. Impact on the financial system and society. For financial institutions, which may be a bit surprising, but it will lower operation cost. They will get a better understanding of the risk and freeing up resources for strategic tasks. The financial system will be more resilient and more efficient. The real economy will profit from a more financial system, and society at large will profit from improved financial market transparency, and it will level the playing field between buyers and sellers. So this will provide the foundation of a future digital financial infrastructure. Now we have a number of challenges. We have a number of financial challenges. This risk assessment methodology, forward-looking versus backward-looking. bank liquidity under absence of risk-free assets, model risk and its influence on capital requirement, and finally, atomic financial system simulation. As the second part concerns the architecture of the integrated automatic financial reporting ecosystem, we will develop a scalable infrastructure for standardized automated financial analysis. Blockchain, smart contracts, and DeFi will be integrated, and models and methods for flexible on-demand analysis for regulatory reporting will be developed. So I focus on the second part here. This one I don't do in this talk. So let's come to the specific things. The container-based infrastructure. Here, this is the scheme I have already shown, and we must break it up into elements. So we are using so-called containers. What are these containers? I mean, IT-savvy people do know it. They are portable, easily deployable, standalone, and executable software packages that include everything that is needed to run a piece of software. So it includes code, it includes runtime libraries, it includes system tools. So here it's sketched. You have here, maybe have Java, a Java compiler, runtime library, you have here an R script, you have Python, and all this you bundle together in such a container. So there are a number of advantages. These containers can run in isolation. They encapsulate the application and their dependency, and they ensure the isolation from the underlying infrastructure. Nevertheless, they stay resource efficient because they use the host, the operating system kernel, which is much more lightweight than traditional virtual machines. They are scalable. Containers can be quickly scaled up or scaled down to meet varying demands by simply starting or terminating additional container instances. And they are modular. Complex applications can be broken down into containers or assembled from containers. And the scalability of the infrastructure depends on these properties. Now, there are two well-known containers. There are the Docker containers. There are the Kubernetes containers. For development, the Docker containers are a little bit more handy because they are easier to construct and implement. The Kubernetes container are more difficulties to handle, but it's easy to scale up in a production environment. So we have deployed at our university a Kubernetes cluster with the help of our ICT department. It was the first such cluster. And we containerized our demo application and deployed it to this cluster. So this cluster, we will then use it in the coming years to experiment with scalability of the DATV3 technology. What we already have at the moment, we have, in fact, two containers. One runs the ACTUS server, and the other runs a user interface with the demo application. What we are in the progress of building is, in addition, a portfolio creator and a risk service that uses the new developed risk API that Francis presented this morning. And planned, there is a container for stress testing and then a container for the result database. So before we had our demo app deployed on the publicly available server for Shiny applications. A Shiny application is an application that where you construct interfaces at the R platform. Shiny is an R package. And it sends the requests to the ACTUS server, and there is a database attached. And this part is located, I think it's all located in the US. You can get a Shiny account, and the smallest one is free of charge, and there you can deploy such applications. But now we have deployed it on our Kubernetes cluster. So we have here the two Kubernetes modules. Now, as to the modeling technology, here again our scheme. What we have to look at is this part. We have the ACTUS contracts with the contract data and the cash flows that are generated by the contract algorithm, and we need the interface to the risk models. And on the other side, we have the cash flows that are generated. Yeah, this is, I call this ACTUS data operations. So in addition to the data dictionary, the ACTUS data dictionary and the ACTUS standard contract types, we need an API for the input, which is the risk factor API, and an API for the raw results, which are the ACTUS contract events. This API already exists, but in the ACTUS documentation, it is not really mentioned. Now, I would like to, I have here a kind of theoretical slide. It's called the Barbotoy structure of the financial system. In fact, this is a property that you have for many complex systems, for instance, also the metabolism. And it's the reason why this ACTUS approach works. Because we have a variety of input, many different financial instruments or many different uses. The point is that all this uses contracts. I mean, we had this wonderful talk of Francis who made this clear. And these contracts must be standardized. They contain, in fact, they get standardized input data and they contain the rules. And the point is that this enormous variety of financial contracts, if you focus on the cash flow pattern that are produced, are not that much. And they can be generated by kind of 30, 40 different contract types. And then you generate, by adding the external risk factor models, as output cash flows, which are also very easy. You only have money. You must use different types because for the downstream analytics. And then you can produce a whole variety of output. So we have here a central processing part. This is the core processing part. And this core processing part must be highly efficient, reliable, transparent, and it requires the standardized data and algorithm. And this is what ACTUS provides. And it's because of this special structure of the financial system that it works so well. I mean, in metabolism, if you look at the elements, the molecules that are responsible for the energy transformation, you have something similar. You have a small variety of molecules that are highly efficient. So, and here, this is a different kind of view of the structure of the logic of the ACTUS processing. We have here the contract terms. According to the data dictionary, we have the risk factors. They come together and the ACTUS algorithm produces the cash flows. These are the raw data, and you have an enormous amount of raw data. If you take a bank, only a small bank with 10,000 contracts, and you run a Monte Carlo simulation, let's say with 1,000 paths, which is not that many, you have 10 million cash flow streams. And these must be then in the analytics aggregated. Why is this aggregation efficient? it's efficient because from the mathematical point of view, it's mainly linear operations. Here, I will skip this slide because Francis already explained the externalization of the risk service. This also I will skip, you already have seen it. And then I would like to demonstrate the working of the whole environment. So we use the prototyping language R as our modeling environment. We have built an R package, FEMS-DEV package that facilitates, that provides the tools for the modeling and simulation that we need. On top of this, we built GUIs by the Shiny package, and then we can use it locally. We can install it easily thanks to the Dockerized components. Now I will show you the demos. First, we have the ACTUS reference service version with the externalized risk server. It's a risk with the risk factor API 2.0. This I again refer to Francis. And we have the R package, the FEMS-DEV package. And then we have deployed two demos. The first one was a basic one that we have since 1.5 years, and the second one is the new one. And it's still working project, but it shows what can be done and what will be done in the coming months. And I will try to start it, and I hope that it should work. At least yesterday it worked. So this is the landing page. Here you can specify your financial model. We have a default model, but I will enter here something, you already see it. You say, okay, this is our model M1, and we have a description, model bank, and we have an enterprise ED bank 1. So you can here upload your own data. I will not do it now, it will take too long. And you can also here upload your own portfolio, which I will not do neither. We have here a test portfolio. You have here the structure of your model. We have the assets, we have the liabilities, we have on the asset side, we have current account, short-term and long-term assets. At the liabilities side, we have just debt and equity. And then we added a point for operations where we put the operational cash flows. And here you see the contracts that we have in the system. There are only 6, and here you see where these contracts are located in the tree of the institutions. So you can then also choose the status date. This is where the simulation begins. You can report you can choose the reporting frequency, and you can also custom the report dates. I will not do this. I just use it like this. Then the next step is not yet available, but here you will be able to modify your portfolio. You may change a contract, you may delete a contract, you may add contracts. Here we come to the simulation. We have a scenario ID as 1. We choose different yield curves. Let's say we should choose a steep one, and here we have a scenario either steady or rising, or okay, let's stick with the rising one. We have falling, recovering, and you can also customize a scenario. And you can upload also a CVS file for additional risk factors. And then we can simulate the stuff. And here you have some log of the simulation. So we have the generated events are okay, the reports are okay. Yeah. So here we have the results. This is a liquidity report. We have no operational cash flow, so you have here 0. This is aggregated liquidity at the top. We have the liquidity on the asset side. We have the liquidity on the liability side. And if you add these two values, you get the one at the top. You can here choose a scaling factor. Let's say we put it in thousands, then you see liquidity in $1,000. You can put it in millions, but then you need some digits, otherwise you will see nothing. So you can customize your display. Then you can here have a drill down, so you can just say, I would like just to see the asset side. And now I can here choose a contract, ANN 003. Let's put this one, then you only see this one. So here we will add some features so that you can go to the contract and then display the cash flows, but this is not yet finished. So here we will implement different key performance indicators which are not yet. This is a mock-up at the moment. So you can select them, and then they show red if they are in the. Let's see here, for instance, it's the current ratio, it's equity ratio. No, yeah, equity ratio. No, it's not equity ratio, it's liquidity ratio. It should be 1. If you go to 1, it becomes green. But here you just choose the values. These values are not calculated. And then we have a last tab where we have a first very easy financial report. In fact, it's a line of the Swiss interest rate risk report. It's a line 32. So here you must pay attention because the reporting line description is here. So this is displaced. The reporting line is 32. The time buckets are displayed here. 1 is overnight, 2 is 1 to 30 days, 3 is 1 to 3 months, and so on. So here's the number of the time buckets. Here's the currency. The type of the cash flow, IP, is interest rate payments. I can choose it here. I can choose, no, this is the scenario where are cash flow types. Here can show the principal redemption. So you see different numbers, and you can also choose different interest rate scenarios. If you change the scenarios, here you get the numbers are adjusted. So it's immediately recomputed. So that's my demo. I will stop here, and we'll go back to my presentation. In fact, I'm nearly at the end. So to conclude, the aim of our project is the creation of an ecosystem for automated regulatory reporting. And as to the modeling approach, we use the ACTUS technology as infrastructural element. We add elements needed to the model and the simulated financial. So we do the modeling and simulating financial institutions. It's done by an R package that we have developed. And also Francis played an essential role in this. From the IT perspective, we use a modular approach using Docker or Kubernetes models. We have implemented a cluster at the as our university. The demos is based on R and Shiny. And then I would like to add something that is not on the slide. One of our goals is to lower the threshold for using ACTUS by providing these demos and by providing additional introductory material that is not yet available. And the second is, you have heard it from Moritz Carver from the ECB. We have the collaboration to map the ANA-credit data onto ACTUS and to use these elements, these modules that I have shown you for the risk analysis of the ANA-credit data. So that's my talk, that's my message. Thank you very much for your attention.
Fantastic. I have to say that what really is great about this project that you're leading is that it's one thing for us to say ACTUS can do everything, including sliced bread. It's another to build a model system that in fact deploys it, and demonstrates its use in these important applications. I just think it's outstanding. Thank you.